Hey, welcome to the Unknown Wires number 2. I'm so stoked to talk about this one. The Pragmatic Programmer by David Thomas and Andrew Hunt. So, this is one of the most recommended books. If you're a seasoned developer, then you would have probably heard about this and read this, in fact. But if you're new to the field, this is one of the most advocated books, or at least in the required reading list. And this is unique. It's a collection of various different items, a lot drawn from the author's experiences in working in and managing teams and projects. So, even though much of it talks about refactoring, programming patterns, best practices, it also has a lot of non technical and important advice for working in teams. So, actually, it's a big collection of very useful ideas across different stages and parts of the entire software business. If you have some experience in the field and you have not really come across this book before, I would say you would probably know a lot of these things, which I will mention here. But it's still very interesting read because there are so many things that you can still pick up from this. But if you're new to this field, in programming or software development in general, then this is a must read, as everyone else also says. One important thing though, which I would also highlight or repeat when talking about such books and in all the following podcasts as well, that if you have zero experience in programming, then I would really wait a bit before you pick this book up. And this is because once you have some experience, then you can actually connect all these ideas and then they stick more. And when you're reading such a book, then your mind goes like, oh, I could have done this. Oh, I could have done that. And that's a more useful lesson. So just something to keep in mind if you're new to the field and you think like, hey, you know what, I want to start with this book. Of course, I'm going to not deny or not advise against reading such books. In fact, you should read as many of such books as you can. In fact, that's also mentioned in this book. But my general advice is when it comes to reading books on programming patterns or any such similar books that give you advice on software development, I think it's better to hold on till you have some experience in doing that. And the kinds of books you can go in cold or which actually meant to be to be approached cold are tutorial books, like those hands-on ML book or the one on fast AI, something that you don't really know anything about, and the entire purpose of the book is to introduce you to some concept. And in fact, that's the same thing I would discuss when talking about the next book, which is, I guess, the topic for the next podcast, which is game programming patterns. But again, I'll talk about that later. But what I'm going to begin with is something I've written down on a piece of paper and have it on my desk all the time. And it's something the authors begin with. And they're like, hey, what makes a pragmatic programmer? And they highlight 5 key characteristics. First, you have to be an early adopter or fast adopter. You have to be inquisitive. You have to be a critical thinker, realistic, and jack of all trades. So, of course, this feels common sense, but it needs to be highlighted because what happens is when you're busy with work, you really don't get time to keep an eye on what's happening in the field. And this field is evolving rapidly. There are so many new things that are coming out. If you're a web developer, there are so many web frameworks that come out. And of course, you don't have to follow all the hype, but you should get an idea of what all of this is about, because someone always creates something new, a new tool, a new framework, because they're like, hey, the previous one has this particular flaw, so that's what I want to fix. And you can just take that pattern and apply it to whatever you're doing. But also, you can see with AI, right, is suddenly become so big, and a lot of people, they're scrambling to learn what that is. And even if you're in a position, say backend development or web development, where you don't really require using any of these statistical models or deep learning models, it's just good to know about all of them at high level. Inquisitive just means you always have to ask questions, or you have to be really curious and hey, what is this? Hey, what's the new thing that's come up? Or, just to quote the book, it's like, hey, that's neat. How did you do that? Or did you have problems using a particular library? Or what's this quantum computing I've heard about? And how are symbolic links implemented? You can, in fact, this is also a very good recommendation I would give is in your office, go find the coffee corner and really chat with all the senior devs, because not only do they have a lot of experience, but they also have a lot of opinion on stuff. So you can just talk about UI frameworks and why one UI framework is better than the other framework or not. And I've done this. I myself am not part of the UI team, and I just learned React as a hobby, but I still spend a lot of time talking to one of our senior architects and just debating about which UI framework is better and which is not, and how Windows has like so many of these UI tools and stuff like this. And you always get a lot of opinion, and that's really it's really insightful, because someone else has already spent a lot of time thinking about it, but you also gain so much because the conversation then really goes in a different direction. But yeah, that's enough on being inquisitive. You have to be a critical thinker. uh, Again, this goes without saying. You always need to ask, like, hey, but why? Why is this done? Or why is this implemented in a certain way? And if a particular library has certain promise, you should also be like, uh, is it really something that this library provides, or is it something else that this library relies on that's actually providing this functionality? And I don't have any specific examples right now, but yeah, unfortunately, but I think in this field, this is something you will come across very frequently. Okay, actually, one example I can think of is I was working at this startup, which was, I think, still using Bitbucket or something as their uh, VCS. And yeah, the main question was like, hey, why do we use that? Why don't we use GitHub or GitLab? Because GitHub has these nice GitHub actions and stuff like that. And main argument was, hey, we started with this, and honestly, no one has really at this point bothered to, or because it takes a lot of efforts to actually migrate to GitHub. And this gives you some uh, insight. Of course, this is not the best example, because this is the same reason people use Java or C++ code, just because you have a lot of legacy code. But you still need to have a look at stuff, even basic function implementations, like why is this being done in a certain way. I know this one example which a friend gave was, I think they had to uh, I think they pass around raw tuples of points in their methods, not in a data structure, like not in a structure or any object. And the goal was have all these methods manipulate all these points, and these points, these tuples, are the control points of splines, so which are shown on meshes. And yeah, the only example was because this is how we implemented in the initially, and then there's, I guess, a lot of changes, stuff like that. And at this point, touching the entire code is quite tough. I mean, not the best example, because it just shows like one poor practice from that particular tech lead, I would say, who implemented the first thing. But my guess is how it happens with every project is it just went, the scope quickly expanded, and as the saying goes, all temporary solutions are permanent. I guess that's what happened here. And in fact, it's also a good place or time right now for me to say that there's an entire chunk of this book which is on refactoring. There are some other things that I've written on my paper. I might have changed the frequency and the number on this compared to what's in the book. I'll have to find out. But it's about having certain goals. So one of them is learn one language a year and then read one technical book a month. I'm not sure if they had written one a year or one a month, but I would say one a month is a good target. Of course, you're not always going to be able to match this target, but that's all right. I think it's good to have ambitious goals. You should take classes, and first, it's the best way to network and also learn stuff. But I would in fact recommend that you should also take classes in disciplines that are not related to software engineering. So you will actually learn or gain quite a lot of insights from other fields. And you will then think, this always said, right? The best ideas are formed at the intersection of multiple domains. Then the book also says, hey, participate in local user groups and meetups, which again goes without saying. And experiment with different environments. Actually, this is very interesting. So if you're just used to working with VS Code on Windows, try switching it up. Try using Vim for a while, and maybe connect to a remote server and just use the terminal like that. And try a different editor. These days, there are so many editors that are coming out. I think at the time of recording, Zed is a quite popular alternative to VS Code. And yeah, finally it says stay current. And again, this goes without saying, but it's really nice to have all of this in front of you. So stay current again refers back to being early adopter or fast adopter. And you don't have to go in details of everything, right? You can say sign up for a newsletter or just keep an eye on certain websites which will just tell you what's happening in the field. And staying current is what it allows you to do is, I think one example I can give you is, say, Tori versus Electron. And Tori is an alternative where you share the rendering resources or the web view with your browser installed on your system, and whereas the backend code runs as a Rust code. So it gives a lot of advantages in lower memory usage and speed. And say you are working in a team that does not even use any of you don't make desktop apps, but it's good to know, like, say when this story came out, you're like, hey, you know what, so this is a good idea that people actually share WebView and then use a Rust code at the back to speed up desktop applications. And even if you don't use this particular tool, which say at that time was new, you might end up utilizing some of the patterns, right? And that's what's important. And I forgot the name. There is a new sort of framework created by or released by Facebook, which claims to solve some of the issues with CSS. And again, if you're not a front-end developer, I think it's really good to know. I think people who know this the best are researchers and academics, because you don't have time to read all the literature that keeps coming out. But what they do is they read all the abstracts and just get an idea of gist of, hey, what's this paper about? In fact, these days is even easier because you have a lot of YouTube channels who summarize, say, the latest ML news or X and Y time, something like that. And I would totally recommend it. Like, have some sort of a routine around it. Like, spend 30 minutes a day or even 15 minutes a day just keeping an eye on all of this. And final set of things which I have on my paper, which are related to refactoring and nothing related to the characteristic of a programmer, are something I've seen come up a lot in a lot of code. Is code should be easy to change, don't repeat yourself, that's the drive principle, and design by contracts. And you'll be surprised that a lot of the times that this is missed. A lot of the times people, especially with Python code, has become so much. Uh, if the team does not have proper programming discipline, or if they're pushed by deadlines, they tend to cut corners, and then your contracts are basically thrown away. And it's, of course, it's not easy to make contracts when you're starting a project, especially because you don't know where it will go. But you need to have some idea on how the interfaces look. Otherwise, your code becomes coupled. But bit of a distraction. I'll talk about this in detail later on. But yeah, this is what's on the paper in front of me. Some really good lessons. And yeah, let's start with, I think, one of the initial themes, something or initial chapters. Something what's super important, which comes up, is you should always see the big picture, even if you're working on a certain part of the project. And in fact, I would say it's also the responsibility of higher level management to kind of present the big picture to everyone, so that everyone knows what they're doing, how the stuff comes together. And there is this line that I've highlighted, which says, so it says that all those in Middle Ages in Europe, when people built, all the carpenters and stonecutters and all, they used to work on all these cathedrals and these large projects which took generations. So they didn't even live through the time of their entire efforts, and they used to pass down the lessons learned to the next builders. And I'll just read the whole paragraph. It's really beautiful. So it says, there should be engineering software construction. However, this doesn't preclude individual craftsmanship. Think about the large cathedrals built in Europe during the Middle Ages. Each took thousands of person-years of effort, spread over many decades. Lessons learned were passed down to the next set of builders, who advanced the state of structural engineering with their accomplishments. But the carpenters, stonecutters, carvers, and glass workers were all craftspeople, interpreting the engineering requirements to produce a whole that transcended the purely mechanical side of the construction. It was their belief in their individual contributions that sustained the projects. We who cut mere stones must always be envisioning cathedrals. It's such a beautiful line. Another lesson that is there in the very next page, which I feel is super useful, because I've worked on, or at least part of my job, I work on different projects, and both teams have different philosophies. So one of the project is very small, so they have a small team, and people in the team really care about their project. They always see a piece of code or see how the CLI looks like, or how your configuration file looks like, and they're never satisfied. They're like, hey, we can improve this, we can improve that, or this can be made simpler. And the other project is bigger, with a lot of teams working from different geolocations, and the other team does not have any such sort of passion or care for the bigger project. So there is never discussions on, hey, how about we make this configuration file simpler, or stuff like that. And what happens due to this, or what is happening due to this, is that the project with smaller team actually has a lot more users and external contributors than the project with a larger team. And yeah, I would just read this page just because, again, this one is also pretty beautiful, great story, which says how you should keep improving every day. And I'm saying it in context of project, and I mean, that's what this book also talks about. But again, you can take this lesson outside of just software development. But it goes like this. A tourist visiting England's Eton College asked the gardener how he got the lawn so perfect. That's easy, he replied. You just brush off the dew every morning, mouth them every other day, and roll them once a week. Is that all? Asked the tourist. Absolutely, replied the gardener. Do that for 500 years and you will have a nice lawn. So that's the thing with refactoring, with anything else, it's just small amount of daily care, even with your personal goals, habits, and this actually small change. It's called Kaizen. This is a Japanese term. In fact, there's a whole great book on this, and the same term is actually mentioned here. But again, something to keep in mind. Care about the stuff you do. Care about the kind of art you're doing. Even if you're working on a small fraction of a larger project, have the bigger project in your mind. Like, the line, we who cut mere stones must always be envisioning cathedrals. It's a great line, maybe make a tattoo of it. The next topic is also such a great one. It's titled The Cat Ate My Source Code, and which is basically, hey, don't, or hey, accept your mistakes. Says pragmatic programmers take charge of their own career and aren't afraid to admit ignorance or error. And it also says when you make a mistake, as we all do, or an error in judgment, admit it honestly and try to offer options. I think this is so close to what I think Jocko Willink says on extreme ownership. But I mean, this is so true. First, the fact that no software is free of bugs is because we programmers are humans and we do make mistakes. And I've seen a lot of senior programmers who just part of their ego or something, they don't really want to admit their own mistakes, or the fact that, hey, their initial design might not have been as up to the requirements as it should have been. And then they kind of blame other junior engineers. Does not happen very frequently, which is nice. But always take responsibility. Take responsibility for your code. But what really helps is then offer solutions. Because like, hey guys, I made a mistake and this is how we can solve it next time, or this is how we can avoid it. In fact, I will give an example. It's a classic intern example. Feels like it's straight out of meme. But when I joined the new team, I was just playing around with Git. Of course, I wasn't, except for basic commit and push pull, I didn't really use Git that much. So I hadn't used Git amend feature and few more important ones, especially one which I'm going to mention right now is Git mirror. So those of you know what Git mirror is, you probably know what happened. But basically what happened is there were some changes for which I had to change the history a bit, basically squash some changes and push them. And of course, being an idiot, I searched on the internet and copied commands without really reading what they do, looking at the man pages and all. So somewhere, I think on Stack Overflow or something, I found Git mirror because, I wanted to fix the branches I have locally, delete the ones I have locally, and then fetch them again from remote. But now what happened is, because I entered Git mirror, what it does is it ensures that the remote has the same branches as you do locally. So because I hadn't fetched all the branches, it started deleting branches from all my colleagues. And when I started reading it on terminal, I was nervous. I panicked, pressed Control C, Control D, Control Z, all the commands I can do to suspend, stop the terminal execution. And I called my team members up, two of them, like, hey guys, quick call. Because I wanted to tell on the call that, like, hey, I messed up. And At the same time, as soon as I got on call with them, actually started receiving messages from other colleagues who were part of the team, like, hey, why did you delete our branch? Stuff like that. And I added one person from the other team on the call and explained, like, hey, you know what, this is what I was trying. This is what I ended up with. And yeah, I'm terribly sorry for this. And I hope people have backups locally so that they can push the changes. So, of course, everyone else, senior engineers, they're all nice. So, some of them joked about it, like, yeah, I didn't use that branch anymore, or like, hey, can you just share the command so I can also do it? And but what they did is, instead of accusing or saying like, hey man, what are you doing, or providing a lot of heat for it, they're like, okay, you know what, let's protect these branches and let's put on these rules, and so just to ensure that this does not happen again. And which is nice. Of course, I wasn't the one who offered options, but I think this really helps in teams, is that of course everyone's going to make mistakes, and if you build a environment where people can make mistakes and are not really punished for it, not even punished, but they don't feel really bad about it, I think it's healthy, right? Because of course I didn't make that mistake, but I was also afterwards, after that incident, really careful on everything else. And of course, as an intern, I think everyone goes through it. But it was interesting. It was interesting how this situation was dealt with, and how, like, one of the engineers, without saying anything at all, he just said like, hey, you know what, these are the things we're going to implement to ensure it does not happen. And this is such a great example of just offering options. And for rest of the team, it allows everyone to take responsibility. But I'm sure every team is like this. The main thing of the book is like, hey, you have to take responsibility of your code, and not just code, whatever you do, and you can't blame it on others. And what helps, of course, is offering options, because that's the solution forward. Otherwise, nothing has really changed. And I'm going to read a passage from the book which says, which is actually titled Provide Options, Don't Make Lame Excuses. So it says, before you approach anyone to tell them why something can't be done, is late, or is broken, stop and listen to yourself. Talk to the rubber duck on your monitor, or the cat. And instead of excuses, provide options. And this is something for me as well, something I have to come back to, or I had to come back to, something. Having read this, I'm glad I knew this. Of course, I'm not an intern anymore. I'm at a senior position. And now when I have discussions with architects or other people in different teams who have a solution, there are so many times I'm like, oh, this is not going to work. It has this issues, it has that. And I feel that, of course, didn't help anyone, because it's like, hey, so what's the solution? And yeah, so at that point, when I can hear myself thinking about this, I'm like, hey, so what are the options here? Why did we even decide to take this particular approach? And are there alternatives? Are there better alternatives? And if there is no solution for this, how can we mitigate the risks? And then when you go to people with not just your complaints, or not complaints, potential issues, and then you also provide them options, they can also factor this in their design, and then it's a productive conversation. And in fact, what was mentioned right now, rubber duck on your computer, I'll quickly talk about this because it's a very interesting concept. Of course, I think many of you would have heard about this, but it's called, I think it's called rubber ducking. But when you talk about a problem to someone, that also helps you in figuring out the solution. And that's why pair programming is actually quite popular. So you just talk through issues. And rubber ducking is basically, hey, you have a rubber duck on your desk. It does not have to be a rubber duck. And then you say, or just explain the problem. If you have an issue, just walk through it verbally. The next chapter is software entropy. I think it's such a great chapter because not because it says something super new, but I think the term it describes. So in software engineering, we call something as technical debt. Is like, hey, you know what? We know this is an issue, but we're going to pay it back in the future. But the authors, they call it software rot because, I mean, because they also say like it can spread uncontrollably. And I've seen this happen. I've seen this happen when the initial design is about to be changed, but people are like, hey, we have to meet a deadline, so let's roll with it. And what you do is you're introducing technical debt. But I think this is the best term because you're not introducing just technical debt, but you're introducing faulty code on purpose, or not just faulty code, I would say unstable code or hard to parse code. And so you're adding software rot. So this chapter actually talks about so many, or gives so many analogies. I think I'm just going to name all of them. But one thing, before I go into that, I want to say they do mention like, hey, where does this even come from? So it's the psychology or culture at the work or on a project. And I completely agree with this because the teams or projects I've seen it happen are where there is a lot of like deadline. So people have to do or have to roll with stuff, even though, I mean, it's not the best way to approach. And because people have hard deadlines, there's sometimes when you make a plan, it can't be executed the way you want it because you inevitably end up with a roadblock. Maybe some technology that you thought would work does not handle one particular case, or your design does not encapsulate everything. And at that point, if your manager or basically the culture of your company does not allow you to basically hit the brakes and then solve or revisit the problem, it introduces technical debt or software rot because then you create workarounds and very hacky workarounds. And I can tell this from experience. I've worked on such projects where you're like, hey, the deadline for implementing this feature is next Tuesday and it's, Wednesday this week. And then you're like, okay, let me start working on this. And then, by Friday evening, you're like, hey, so the stuff I'm trying to integrate has this particular edge case that your design does not take into account. And then you get a message like, oh yeah, that's all right. You know what, let's fix this later on because we have a deadline to meet. And especially actually with pressure, people actually don't even spend a lot of time thinking of the best way to implement stuff. So that's a major cultural issue. Of course, like I said, it depends on project to project, teams to team. And because I work in multiple teams, only certain teams suffer from it, which is nice because I can actually breathe. I feel better in the other teams. But anyway, this book talks about broken window as an analogy. And it says one broken window left unrepaired for any substantial length of time instills in the inhabitants of the building a sense of abandonment, a sense that the powers that be don't care about this building. So another window gets broken, people start littering, graffiti appears, serious structural damage begins. In a relatively short span of time, the building becomes damaged beyond the owner's desire to fix it, and the sense of abandonment becomes reality. And it says, hopelessness can be contagious. And again, part of the text which says, don't live with broken windows. So don't leave broken windows, bad designs, wrong decisions, or poor code unrepaired. And take some action to prevent further damage and to show that you're on top of the situation. Don't cause collateral damage just because there's a crisis of some sort. One broken window is one too many. One broken window, a badly designed piece of code, a poor management decision that the team must live with for the duration of the project is all it takes to start the decline. And in fact, this comes from the broken window theory of a psychology study. And it says, in the original experiment leading to the broken window theory, an abandoned car sat for a week untouched. But once a single window was broken, the car was stripped and turned upside down within hours. By the same token, if you find yourself on a project where the code is pristinely beautiful, cleanly written, well designed and elegant, you will likely take extra special care not to mess it up, just like the firefighters. Even if there's a fire raging, that's deadline, release date, trade show, demo, etc. You don't want to be the first one to make a mess and inflict additional damage. Just tell yourself, no broken windows. And this goes back to the example which I gave, that what ends up happening is, if you don't sort of fight back, the kind of attitude which certain teams have, like, hey, you know what, let's just roll with this design and see what we got, or hey, we got to implement this feature by so and so date because we have a code freeze and then feature release. You should try to fight back. Of course, not everyone is in the same, say, seniority level to have that influence, but at least raise it, and so that it's documented somewhere, and so that other people also feel, other programmers, because many people are probably having the same thought, and they also feel like, hey, I'm not the only one to think like that, and that's going to start a discussion. So this one's a great chapter, Stone Soup and Boiled Frogs. Amazing story. I'm just going to read it out as is. The 3 soldiers returning home from war were hungry. When they saw the village ahead, their spirits lifted. They were sure the villagers would give them a meal. But when they got there, they found the doors locked and the windows closed. After many years of war, the villagers were short of food and hoarded what they had. Undeterred, the soldiers boiled a pot of water and carefully placed 3 stones into it. The amazed villagers came out to watch. "This is stone soup," the soldiers explained. "Is that all you put in it?" asked the villagers. "Absolutely, although some say it tastes even better with a few carrots." A villager ran off, returning in no time with a basket of carrots from his hoard. A couple minutes later, the villagers again asked, "Is that it?" "Well," said the soldier, "a couple of potatoes give it body." Off ran another villager. Over the next hour, the soldiers listed more ingredients that would enhance the soup: beef, leeks, salt, and herbs. Each time, a different villager would run off to raid their personal stores. Eventually, they had produced a large pot of steaming soup. The soldiers removed the stones and they sat down with the entire village to enjoy the first square meal any of them had eaten in months. There are a couple of morals in the stone soup story. The villagers are tricked by the soldiers, who use the villagers' curiosity to get food from them. But more importantly, the soldiers act as a catalyst, bringing the village together so they can jointly produce something that they couldn't have done by themselves. A synergistic result. Eventually, everyone wins. Every now and then, you might want to emulate the soldiers. You may be in a situation where you know exactly what needs to be doing and how to do it. The entire system just appears before your eyes. You know it's right, but ask permission to tackle the whole thing and you'll be met with delays and blank stares. People will form committees, budgets will need approval, and things will get complicated. Everyone will guard their own resources. Sometimes this is called startup fatigue. It's time to bring out the stones. Work on what you can reasonably ask for. Develop it well. Once you got it, show people and let them marvel. Then say, of course, it would be better if you added. Pretend it's not important. Sit back and wait for them to start asking you to add the functionality you originally wanted. People find it easier to join an ongoing success. Show them a glimpse of the future and you'll get them to rally around. Again, great lesson. This one is actually on team management. And like I said, authors, they draw from experience of the entire career. So not just programming, but stuff like this. And I've seen this happen so many teams. There are some people who really take the initiative. They're like, hey, you know what? Especially in big companies, it's hard to do anything. You have the marketing team, you have the legal team, you have people who do the security checks, and proposing any of this requires a lot of meetings, a lot of discussions. But there are people who will create one small PR. Maybe it's adding some sort of linting check or some refactor, and then they will because of the PR, everyone else is like, hey, this is a good improvement, let's merge it. Then there's another PR, and then you have discussions like, hey, so I was thinking, how about we do the same thing for this particular part and for that particular part, and everyone basically jumps on board. And again, great example which I've seen in practice, and something you can implement if you feel that there are processes that restrict you from doing a change that's meaningful. And of course, you got to understand that the context here, because we programmers, we are introverts, and like artists, we feel like our code is the best, our design is the best. Don't do that. It's a fallacy. Always work with the team and ensure that whatever design or change you propose is actually good. And you can do that by even talking to a few people. If they all agree like, hey, this is a good design, then you can sort of guide the senior leadership in a certain direction by taking such small action. Actually, on the note of software programmers or programmers treating themselves or having the same mentality of an artist, the next chapter is again next topic is super useful, or kind of like puts stuff in a realistic frame. So it's titled Good Enough Software, and says time, technology, and temperament are all conspiring against us. So you'll never produce a perfect software, one that's bug free. In fact, I always mention like it's really surprising that so many of the software works, because we write tests to ensure that the software works, but who ensures that the tests themselves are correct or not? So you have a broken piece of code, or say punctured piece of code, because it's not always thorough, which ensures that the rest of the stuff works really well. And this chapter actually says, like, surprisingly, many users would rather use software with some rough edges today than wait for a year for the shiny bells and whistles version. And in fact, what they will need a year from now may be completely different anyway. Many IT departments with tight budgets would agree. Great software today is often preferable to the fantasy of perfect software tomorrow. If you give your users something to play with early, their feedback will often lead to better eventual solution. I think this goes in line with the whole lean startup ideology. But in this case, it's more like the artist sort of way of thinking, like, oh, I want it to be perfect, or I can't really release it till the time, this thing is sorted or not. It's like the 80-20 rule. Once it's good enough, once you feel like, hey, I can ship it, you have to hand it to the users. People should use it. In fact, that feedback is going to be more important. It does not matter if the indentation on your log outputs are not as what you'd expect, or your color scheme is off. Of course, this feels like, oh, this is such a ridiculous example, but it's happened. um, Personally, I don't want to it's happened to me. I'm like, hey, you know what, I really want this particular log to be written to this particular file and this particular format, and it's just bothered me because it's not good enough. But this chapter is all about, hey, what's good enough? And to close with, I think this is the best line of the chapter: don't spoil a perfectly good program by over embellishment and over refinement. Move on and let your code stand on its own right for a while. Knowledge portfolio. So this one jumps back to characteristic of the programmer, and something we discussed earlier is you have to keep learning new stuff, and starts with the quote: an investment in knowledge always pays the best interest. This is by Benjamin Franklin, and it says, right, our knowledge and experience in our day-to-day profession is an expiring asset. So they say, unfortunately, they are expiring assets. Your knowledge becomes out of date as new techniques, languages, and environments are developed. Changing market forces may render your experience obsolete or irrelevant. Given the ever-increasing pace of change in our technological society, this can happen pretty quickly. In fact, the best example here is from portfolio managers, and in this case it's said, or it's the analogy here is, you should treat your knowledge as any financial portfolio, and it's called the knowledge portfolio. It says serious investors invest regularly as a habit. Diversification is the key to long-term success. Smart investors balance their portfolio between conservative and high-risk, high-reward investments. Investors try to buy low and sell high for maximum return. Portfolios should be reviewed and rebalanced periodically. And to be successful in your career, you must invest in your knowledge portfolio using these same guidelines. And again, feels so obvious in retrospect, but so many people should know this, because say you're a backend developer, it's really nice to know a little bit about front end. If you're into AI, again, it's really nice to know something about, because all these researchers who I've worked with, many of them really don't care about any of the technology. They read papers, they write Python code. They're more from mathematics background, but it really does not hurt to know about other fields. Maybe, spend some time studying Kubernetes or Docker, something like model scaling. Maybe look into some new framework that's come up, right? Maybe some new communication protocol. It's always useful to know all of this. And like I said, right, don't put all your eggs in one basket. It's the same thing with software. Or tech field, don't put all your technical eggs in one basket. And buy low, sell high, what does that mean? Learning an emerging technology before it becomes popular can be just as hard as finding an undervalued stock, but the payoff can be just as rewarding. So learning Java, like I'm reading the chapter here. So learning Java back when it was first introduced and unknown may have been very risky at the time, but it paid off handsomely for the early adopters when it became an industry mainstay later. So this is where we actually come back to the points that I had written on my paper. And well, how do you invest regularly in your knowledge portfolio? And is by having these goals, is by learn at least one new language every year, because it says different languages solve the same problems in different ways. By learning several different approaches, you can help broaden your thinking and avoid getting stuck in a rut. Additionally, learning many languages is easy thanks to wealth of freely available software. In fact, after adopting this, because I work mainly in the field of AI and we deal a lot with Python code, and it's more AI tooling, so a lot of object oriented sort of programming. And I've been learning some other programs, especially like a programming language, especially like Rust, which does not have classes as such, but structs and traits and implementations on them. So it's a very interesting approach than functional programming. That's a whole different way to go about looking at how problems can be solved in a pipeline manner. Then of course it says read a technical book each month. So all right, so I thought I had added per month instead of year, but yeah, it's right, it's per month. And read non-technical books too, of course, because it's good to know about psychology. It's good to know about even the book says, right, you shouldn't forget the human side. So these are all the soft skills. In fact, the higher you rise in your career, the better you are at soft skills, the better your team will work. And even if you like it or not, the higher you rise in your career, you'll find yourself doing less programming and dealing more with people. So even though companies require people with more experience, as soon as you have more experience, you're kind of not allowed to apply it, or you just don't end up. So I think this is a start early, start reading a lot of journal books early. And the thing about technical books, I would say, is like going back is right now you have access to a lot of quality resources. I mean, just go on GitHub and see recommended reading lists. And so many people have compiled the books they think are the best. And so it's also easy for you to pick sort of like high return books, right? So you don't have to do it yourself. It's like having a financial advisor for picking stocks, following the same analogy. That's what I would ask. And if you're comfortable with one thing, just move on, learn something new. And it's also with hobbies. If you're comfortable with playing guitar, why don't you pick up piano or drums, or flute, something totally different. And then there's a section of opportunities for learning. And you don't have to just limit yourself to books, right? Books are great, but talk to people, talk to other people. And it says like talking to other people will help build your personal network, and you may be surprised, or you may surprise yourself by finding solutions to other unrelated problems along the way. There is this concept called use the dead time, and it's something which actually explained well in the book. I mean, they don't use the term dead time, but it's like all this reading and researching takes time, and time is already on short supply. So you need to plan ahead. Always have something to read in an otherwise dead moment. Time spent waiting for doctors and dentists can be a great opportunity to catch up on your reading. But be sure to bring your own e-reader with you. And which is actually something which my father also says, or actually said long time ago. He always said like, hey, always carry a book. And there have been so many occasions where I'm just waiting for people, or you're in a train. It's the best way to read a book. And being sort of offline is also a good way to just disconnect and contemplate. So you read a paragraph and you can just look outside while the scenery is changing and contemplate on the book, on whatever you have read. And you'll realize in your wanderings of your mind, you actually form connections with some other lessons that you have learned or in some other domain. Critical thinking comes back here. It's one example. Like I said, I couldn't really give an example before. This is great, but it says just because a bookstore features a book prominently doesn't mean it's a good book or even popular. They may have been paid to place it there. And yeah, it's a great example. What does thinking critically mean? And in fact, it actually gives an example. It says, ask the 5 whys. or a technique. It's a technique it mentions. A favorite consulting trick: ask why at least 5 times. Ask a question, get an answer. Dig deeper by asking why. Repeat as if you were a petulant 4-year-old, but a polite one. You might be able to get closer to a root cause this way. In fact, this is something I had come across before as well, and I call it the ladder of why. And where I came across it said like you should do it 7 times, and I would say I think going that deep is, or you'll get an idea once you do it. Anything you do, just get a piece of paper. I like to get a loose sheet of paper because I can just throw stuff, even if it's personal. Like it does not have to be related to programming, but just personal stuff that even if you're dealing with. Then like, hey, you know what? Why do I feel this way, or why do I feel that this situation didn't really go the way I wanted? And just follow the ladder of why, and you'll find the solution. And think about the loose sheet of paper is, then you can just throw it, like destroy it. But so one of the technique, it says ask the 5 whys, but it mentions a couple of other things like figuring out who does it benefit. So it's like, follow the money, and does it benefit somewhere else or some other organization, or is it aligned to your own? And what's the context? Because everything occurs in its own context. And that's why one size fits all does not work. So if you read a book or article says, oh, this is the best practice, then the authors mention good question to consider are best for who? Right? What are the prerequisites? What are the consequences, short and long term? Then what's important is you have to figure out when or where this would work. So something similar to the previous one. This is under which circumstances. Is it too late or too early to do something? And it's, book mentions like don't stop with first order thinking, what will happen next, but use second order thinking, what will happen after that. And the crux of critical thinking is, why is this a problem? Like, is there an underlying model? How does this underlying model work? And next lesson is communicate. And it says, having the best ideas, the finest code, or the most pragmatic thinking is ultimately sterile unless you can communicate with other people. A good idea is an orphan without effective communication. And this is so important. This is important not just in programming, but everywhere. Like, you should know your audience, who you're talking to. So if someone is a technical person, you should be able to go into the right amount of detail. But if someone is, say, from marketing, so they are looking for a different perspective of the solution that you're trying to offer, right? Because they're going to go to the customers with certain solution for a certain problem. And if you can then just focus on the solution rather than the technical details of how the solution is being approached at, is going to be more useful to them. And with communication, one thing that is super important, which I feel we as programmers are not really good at it because we stare at the screen all the time, is body language. So you should really gain some experience in reading facial expressions, body language, and getting a lot of subtext or unsaid communication. And when you communicate, say in your emails or in your meetings, I think the best advice for communication generally is communicate in simple language, because we work in international teams, so not everyone would follow your very impressive vocabulary, which becomes unnecessary or is not useful if the other person does not really understand what's happening. But you should also be clear, the basics, like use short sentences, have an outline of what you want to say, and ensure that the other person has got it. So you should not wait for questions. but you should kind of preempt them and maybe ask questions, maybe engage people. And you also need to understand, what's important is choose your moment to communicate. If people who are busy with, say, a deadline, are or have some other priorities, might not be most receptive to whatever new idea that you would want to present, because at that moment they're swamped, right? But wait for another week when things settle down a bit, and then they might be more receptive. So again, it's a lot of soft skills, but this comes with practice. And unfortunately, I don't think there's an advice for this. It's good to have all these key points in detail, but I would like to say that, or I would insist, is just go out in the world more. And if you can communicate well with friends and strangers especially, I think you're going to do great in company. And I think, like, the best thing which the book says, it gives a couple of tips. I would just ask you guys to read all this part, because again, communication is a whole different. There are books written on communication, and it says, maybe a simple question like, hey, is this a good time to talk about so and so? That's the best way to approach. And then what kind of communication style you want to have. Like, do you want to have just facts, which is like a more down to business kind of approach? And are the experts or newbies? Because do you have to walk them through everything or not? And something what I've learned from, say, my thesis supervisor and my colleague is make it look good. And he spends a lot of time on design and making sure the presentation is nice. And these days with online presentations, when everyone has the camera turned off, and when the presentation was more an aid, now it's the complete replacement. This is even more important. You have to really care about how you deliver your ideas. How do you deliver your code? I mean, when it shows, is a basic example, right? When you want to have some snippet of code in a presentation, you have this website like carbonnow.sh, which creates this nice little windows around your sort of well formatted and color coded, I would say, code. All those variables are highlighted. Yeah, like your highlighted code. Then ensure that the transitions and presentations are great. Ensure that for every key point that you have, maybe have a symbol related to it, because it really helps your readers when you revisit that topic later on to also have a symbol associated with it, because text is so forgettable, right? But when you have images, and when you can guide, when you have a simple icon of a file next whenever you talk about config, it's a great way to sort of anchor people's attention to the fact that, or it works like a guiding arrow, right? Oh wait, so it's the same concept that we talked earlier. So the brain doesn't have to do a lot of overhead of jumping between previously said knowledge. And this is super important. I can talk a lot about it, because I would say, hey, why don't you also study typography online? I did a course, very fascinating. I don't always follow all the rules, but it's interesting to see how fonts, letters, spacing, typeface, all of this also have effect on people, how they perceive it. Having nice color contrast, how it's good, and lot of stuff. Maybe I'll talk about it in a different podcast. Maybe if you discuss, say, the design of everyday things or typography. There's a very interesting website that I came across recently. I'll talk about it, or maybe share it as a description of some of the podcast. or even in the YouTube channel, because this is also going to be uploaded to YouTube, unfortunately without video yet. I need to sort out my camera, and especially when we have guests later on. Oh, and few minor issues, or not minor issues, like minor points to focus on when communication, which is super important, is be a listener. And it says, what I've highlighted here is, even if this is a situation where you have all the information, and this happens, right? This happens so many times in you attending a meeting, and then you have, at least personally, I'm like, oh, I know this, so I just basically turn off. And ideally, it's a good practice to listen in general. Like, there is a sort of saying in improv, which is like, listen like a thief. So you're stealing information, not just the auditory cues, but also visual and body, like I mentioned, body language. And of course, you should always get back to people. You're swamped with emails. Someone always sends you a message. Always get back. Maybe it's a single line saying like, hey, so sorry, I'm swamped. Can you remind me, 2 weeks later or something like that, if I don't respond back? And I think that's a great way to tell people like, hey, I can't really spend so much time discussing this. At the same time, you have not really ghosted them, because it's not really professional. And finally, communication is also super important when it comes to writing documentation, because whatever you have written, if other people do not understand what that is, how to use it, if it's not clear enough, if you have not documented it well, not just as user guides, but within your code, no one's going to use it. It's like having the most groundbreaking discovery, but without any applications. And then 10 years later, someone figures it out, and then kind of you have lost 10 years of advancement, right? If I were to give an analogy or example from physics. But communication is super important in every single aspect of your, not just professional career, but even personal. So it's nice that they have it here. They have focused it mainly towards the professional side, but I would recommend like read a whole book or spend more time working on it, spend more time in developing this skill. Because in my example, again, teams are different, and you have so many different sorts of characters, but I have worked with so many introverts that you don't even realize when they come to the office and when they leave. And you really have to extract information like, oh, what are their hobbies? What do they like to do on the weekend? What are their personal projects? And people have such very, very interesting lives, interesting stories. But they don't really talk about it. And if you're good at all this general communication, it's going to be super easy when you have to deliver presentations or even give a talk to the rest of your team. So invest in the skill. I would recommend it. Chapter 2 is all about, they call it a pragmatic approach, but it's all about good design. And I'm not going to spend a lot of time on it, because I feel design in general, programming patterns and all you should read it. You should look at the sample code. So it's hard to explain online, but there are a few patterns I would say which are super useful, which one of them I've come across so many times that initially it felt like, oh, this is obvious, but apparently it's not. But I'll quickly go over the list. One is, don't repeat yourself. Is, hey, if you have to touch one piece of code and but it affects the other piece of code as well, so, or at least you have to make changes in different parts, then it's not really independent. So you actually have duplication. So you should kind of ensure in programming that you only change one part of the code. Feels obvious, but the fact that the authors have mentioned it here also feels like probably just comes up so many times. And in fact, it does come up so many times. They also mention that sometimes it's inevitable. And then when it's inevitable, how do you deal with it? So I'm not going to go into this because, again, you have to read it, internalize all the examples. And I think there's a big benefit on just reading a book on programming patterns. I think the most famous one is, I think, Design Patterns by the Gang of Four, it's called. I don't remember the exact name. You should have it on your shelf. I feel that's something you should keep referring to. The one I'm actually reading is Game Programming Pattern by Robert Neustrom. I hope I'm pronouncing his name correctly. If I'm not, I would like to apologize. But something I'm going to talk about in brief in the next episode. But it's a great book. It's in the context of game programming. But these are all the patterns which I feel, again, like I feel many of these patterns you have to first program, then read all of these, and then your brain is like, oh, I could have done this. Oh, aha. So this is how it should be done. The second pattern this book talks about, that is pragmatic programmer, is orthogonality, which is if you want to design systems that are, or produce systems that are easy to design, build, test, and extend, then you have to understand what orthogonality is. And it's actually a term borrowed from mathematics. And basically, two vectors, they're independent if they meet at right angles. So if you move basically across one vector, you're not changing your position across the other vector. So that's where it comes from. I'm not going to spend a lot of time on it. Maybe if you really want to go into linear algebra, Gilbert Strang has an amazing series. The MIT, I think, is the famous MIT lectures on YouTube. Go watch those. They're great. I'm going to skip a few in the middle. Again, like I said, programming patterns are something you should read about and can't be, you don't really drive a lot from listening to it. But one thing I would like to spend time on are tracer bullets and prototypes, because these are so important. So what's a prototype? Prototype is, hey, you're doing a POC. In the same analogy of game programming or example of game programming, it's someone comes up to you like, hey, I have this idea. What if there's a player who can jump like this, who has this power, and these are the kind of enemies they are facing. Can you create a prototype? And you're like, oh yeah, I can. And then you create a prototype and it looks nice. And your manager's like, hey, it looks nice. Let's just polish it and ship it. And if you don't have experience working in, there are some teams which do not understand the concept of prototype. And if you don't have experience, this probably doesn't make sense to you. And you'd be like, hey, this is so weird. But I've seen it happen. I've seen the prototype we have been working on, and we showed it to a larger audience. And immediately after the presentation, we got a message from the manager of the project, like, hey, looks like everything is there. Why don't you just, merge it by so-and-so date? And then there was a hard time explaining, like, hey, it's a prototype. It's a skinned version of what actually should be there. It's a separate repo, and not all of this works. And one of the best advice that's given in creating prototype is use a language that's not the same as your target language. And this is something I have sort of internalized, because I feel this has happened so many times. Initially, when I read about it, I'm like, oh, who does this? But after experiencing it, I feel it's super necessary to have prototypes which are like a separate repo, ideally different language, so that you can be like, hey, this is a prototype, it's not in the stage yet, it looks like this, but implementing it from scratch in the final product is going to be different. But that's basically all I want to say about prototypes. Nothing really fancy here. It's just small proof of concept, basic functionality. What's important here is tracer bullets, and this term actually comes from military, which is sometimes, especially in the night when the soldiers they shoot bullets, they also have these tracer rounds which are visible because I think it's their phosphorus trail that they leave behind in the air. So you can also see where your bullets are going because you're not just firing blind, right? And in concept of programming is basically, if you want to say make a change, one way for you to make the change or even do a POC is see if you can have like the one basic feature and implement it end to end. So it's like a tracer bullet through all your layers of your software. So maybe you're making an API change for say export functionality of your deep learning model, right? So you can start from the CLI or the training script from that file and have a simple set of API changes which goes across your repo. So which changes how your trainer kind of looks, how your model looks, how does the model export data, how is export related information stored in the model, and how the final export API looks, and how does inference on this exported model look like. And this is a very interesting pattern because so many times when you are making some breaking change, you need to do some sort of a feasibility study, and having an end-to-end product with the most minimal functionality is the best way to design or at least test your design. So again, read about this in the book, and like I mentioned, this is very similar to the lean startup sort of ideology and the whole incremental approach. So very interesting pattern. And the important thing about this pattern is, unlike prototype, the code that you write is not disposable. So you keep it. So it has all the error checking, structuring, documentation, everything. It's just an end-to-end change, because of course, if you want to make a big change, you can't just change one part and then ensure everything works or not. And this is like if you're working on a single repo, you'd be like, hey, of course I'll have to change everything for it to work. But it becomes more complicated when you have to deal with databases and different microservices. In that case, you'll have to basically look across all these repos, see how all of these parts interact, and then make changes that sort of achieve this feature. The chapter actually ends with the most succinct difference between prototype and tracer bullet. And they mention like the distinction is important enough to warrant repeating. Prototyping generates disposable code. Tracer code is lean but complete and forms part of the skeleton of the final system. Think of prototyping as a reconnaissance and intelligence gathering that takes place before a single tracer bullet is fired. Well, I just realized that we are more than 1 hour in, and I've not even completed 50% of the book. So I think I'm just going to pause here and maybe have 2 more parts of this. So yeah, maybe I'll see you in the next one. Parting thoughts. I think all the programming patterns and design is something that requires its own separate discussion. but something I'll not do in form of a podcast. I'll probably make a playlist on YouTube, and I think that's a great way to introduce the patterns in code. And I would really recommend people that if you do pick up books on programming patterns, just have some experience in writing program, right? Where you use a bunch of classes, where it does a bunch of different things. Because when you read a programming pattern book, I feel like I keep repeating myself, but that's when you'll actually gain insight. That's when you'll be able to connect the dots. That's when you'll be able to be like, hey, you know what? This is what I could have done. But with that said, if you have listened so far, thank you so much for listening. And I'll see you in the next one. So it's going to be Unknown Wires number 3, but with Programmatic Programmer as our ongoing topic.